Hi everyone, this is the video for 5.1, Fundamental Identities. So you have some of your identities that we're going to use this chapter are right there, and then the rest that we're going to learn throughout the chapter are on your identity sheets. And this is going to be your BFF for this chapter because it would be really hard to memorize all of those identities. And we're going to use them a lot. So we have a couple different sets that we're going to talk about today. And these are the basic ones that we use most often. Really, it's the Pythagorean ones that we use a lot. The quotient identities and the reciprocal ones we've been pretty much using since we started learning the trig functions, so those aren't a big deal. And then the negative angle identities relate, like what would happen if you put in a negative angle, what would you get out? So we can talk more about how that works in class. But these Pythagorean ones are the really important ones. We use those all the time. And they're based off the Pythagorean theorem and how everything relates in the triangle. And we'll probably do a proof of it and how it works in class. So remember that an identity is something that you can put any value in for theta and it would be true. So no matter what theta value we plug in, this is always going to equal 1. Okay, so for the first example we're going to do, we're going to use some of these identities and find the secant and cotangent value when it's given that tangent of 3 is equal to 3/5. So I know that in the past we've solved problems like that, but we always draw the picture. So what we're doing here is finding that secant value without drawing the pictures and using how they're related to each other with these identities. And the only reason we're doing this is to get us comfortable with those identities. Okay, so since we were given tangent and we want to find secant, we're going to find the identity that most closely relates secant to tangent, which would be this Pythagorean identity. Okay, so that's the one we're going to use for this. So they told us that tangent is equal to 3/5, and we want to solve for secant. So I'm going to plug in what tangent is in this problem. So that means we would have 3/5 squared plus 1 equals secant squared. And so from here, I would just have to solve for secant. So basically, it's like solving an equation for x. This is my x here, or x squared, and we're going to solve for that. So then we would just do order of operations to solve like a regular equation. So again, we use the identity that relates secant and tangent and plug in what we knew. So this would be 9 over 25. I'm going to get common denominators. If my bottom's 25 and this is 1, that would be the same as 25 over 25. So now we have 34 over 25 equals secant squared. And if I'm trying to solve for just secant, then we would take the square root of both sides. So then we would have plus or minus the square root of 34 over 5 is equal to secant of theta. But they told us that tangent was in quadrant 2. Oh, theta is in quadrant 2. Tangent would be negative then. That's a typo. It should be negative if we're in quadrant 2. But, I mean, it doesn't matter for what we just did because when you square it, it comes out positive. So my whole point with talking about the quadrant is we need to figure out, is secant in that quadrant positive or negative? And since secant goes with cosine, cosine is negative in that quadrant. So our final answer would be that secant theta is equal to negative square root of 34 over 5. So we found one. So we found that using our identities instead of just drawing our picture. Okay, so let's take a look at the other part. So we want to find the cotangent of negative theta. So if we look down here, we know that the cotangent of negative theta is equal to negative cotangent of theta. Okay, so we're going to use this identity to find what this would equal. So I know that cotangent is equal to 1 over tangent, and I know what tangent is. Tangent's negative 3/5, so we can plug that in. And then if we simplify that, we'd have -1 times -5/3. So we would get 5/3. So cotangent of -θ would equal 5/3. Oh, sorry. So there you go. That's what we were looking for. Okay, so that was again using the identities. So let's take a look at our examples inside. So some of these are kind of hard. We're just getting used to our identities. But a lot of it is just manipulating what we have and plugging things in that equal other things to be able to get what we want. So for the first example, it says to express cotangent in terms of cosecant. So again, we need an identity that relates cotangent and cosecant for this one. So that would be this Pythagorean identity right here. Okay, so 1 plus cotangent squared equals cosecant squared. Most of the time when I'm solving problems like this, I just leave the x out or the theta out to the very end and then write it back in. It gets kind of tedious writing it every time. So they told us to express cotangent in terms of cosecant. So basically we want to change this equation so it says cotangent equals, and then on the other side have just things with cosecant and numbers on it. So really what that means is we're solving this equation for cotangent. So just like a normal equation, we would first add or subtract. So then we'd have cotangent squared equals cosecant squared minus 1. And then to get rid of the squared, we would take the square root. So cotangent of x equals plus or minus the square root of cosecant squared x minus 1. Remember, whenever you take the square root to solve an equation, you have to put plus or minus. So what we just did was rewrite cotangent in terms of cosecant. So if I was trying to find cosecant or cotangent and I knew cosecant, this identity would help us solve it. Okay, so the next one is we're going to express cosine in terms of tangent. So we're going to use the identity that closely relates those, and the closest one we have is the one that says tangent squared plus 1 equals secant squared. So I know we want cosine in terms of tangent, but this is as close as we're going to get it because, well, I mean, we're going to do stuff, but this is the closest identity we have because secant 1 over that is cosine. So that's the first thing we're going to do is get our cosine. So if we do 1 over, flip both sides, we would now have 1 over tangent squared plus 1 equals 1 over secant is cosine squared. So now we have cosine and tangent, but it's cosine squared and not tangent, or I'm sorry, not just cosine. So from here we would take the square root. So we would have 1 over the square root of tangent squared plus 1. And it is plus or minus, but I'm going to wait to the end to write that in. Okay, so this is good. This is what cosine equals, but we have a problem. What's the problem? Good, we can't have the square root in the denominator. So just like when we would have numbers with square roots in the denominator, we have to do the same thing, which is rationalize the denominator. So times the top and the bottom by our radical. So the top will turn into tangent, the square root of tangent squared plus 1. And then the bottom, the radicals cancel out, so it would just be tangent squared x plus 1 equals cosine of x. And now I'm going to write the plus or minus in. Okay, very good. Why don't you guys try, well, we'll do the next one together. Just kidding. Okay, so the next few that we're going to do, well, really the rest of them, is kind of the same idea, but we're trying to make everything just be sines and cosines. So instead of changing it to, in terms of something else, we just want everything to be sines and cosines. So we're going to simplify till we get all sines and cosines. So for this first example, we know we're going to have to change the tangent. And then also I have sine squared plus cosine squared. So I'm just going to rewrite them real quick to put them next to each other. So the sine squared plus cosine squared equals something. Very good, that just equals 1. So if I replace that with a 1, now we have 1 plus tangent squared. And if we look at our identities, I know that 1 plus tangent squared is equal to secant squared. So our goal for this problem was first to get rid of that tangent. But if I change that to 1, I can get it to this. So I got rid of the tangent, and I know secant is the same thing as 1 over cosine squared. And now we're in terms of sine and cosine, so that would be it. So basically we change this whole big thing to equal this. So we're just rewriting things to equal other things. Okay, so let's try the next one. So we want to express this in terms of sine and cosine. And then it's not just expressing it in terms of sine and cosine, it's also simplifying it as farther as you can get, as farthest. So there's a couple different ways you can start for this one. I would start by changing this. So we'd have sine times 1 over sine minus sine. So from there I would distribute. So we would have sine over sine minus sine squared. So what can we do from there? Good, sine over sine is 1. And then 1 minus sine squared is cosine squared. So I make sure you have your identity sheet handy for you. Okay, so why don't you guys try those last two first, or by yourself. Look at your identities, especially for this one you're going to use identities first and this one, and then you can do some algebra to try to simplify from there. Okay, so go ahead and try both of those. Pause your video, and when you come back I will show you how to do them. Okay, so for that middle example, the first thing we did was wanted to get rid of that negative theta. So tangent of negative theta equals negative tangent of theta. On the bottom, I changed it to 1 over cosine. So tangent is equal to sine over cosine, and then I flipped the denominator to get rid of the fraction and a fraction, and then those cosines cancel out, so we're just left with negative sine of theta. So if we take a look at the last one, 1 plus tangent squared is secant squared, and 1 plus cotangent squared is cosecant squared. And then I changed them to their reciprocal functions. So now I have 1 over cosine over 1 over sine. So if you flip and multiply, you would get sine squared over cosine squared. And the answers in the back of the book do some crazy things. So if you look at them, they might not be what I want you to have. But like this problem in the book, it would say that this equals tangent squared, which doesn't make sense because we wanted to leave our answers in terms of sine and cosine. So I would just stop there. So that would be it. Sine squared over cosine squared of theta. Okay, so make sure you write down any questions or things you didn't understand, and we'll talk about them in class tomorrow.